Live from the Icebox Studio in Montgomeryville, Pennsylvania, it's the Bill and Corey Show.
I'm Bill.
And I'm Corey.
Welcome back. Another live edition of the Bill and Corey Show.
Yes.
And this week we're going to talk about dichlorosilane.
Yeah.
So before
that's it?
No, equipment for it. But so just to remind you guys, we got the YouTube chat questions all set up, so I can. It's one of these things. I'm watching me. But if you have questions, type them in there.
It's like that video of like when you take a picture of a person in a mirror and then
it just keeps going forever, something like that. Yeah.
So stare into the abyss.
Dichlorosilane. So let's pop up the first graphic. We got a lot of graphics tonight.
Oh yeah, but why dichlorosilane? Did we ever get on that?
We're getting to that.
All right.
Well, actually, we're doing dichlorosilane. We got a cabinet in shop, and then we had some other questions people are asking about.
Well, it feels like we have unintentionally gotten a theme going of like low pressure stuff. I don't know why, but we keep doing that, and this is a lower pressure application as well, which makes it interesting.
So this is a spec sheet. Don't try to squint and looking at it.
Don't worry. It's just supposed to look fancy.
Okay, this is from our corporate website. It's a gas status sheet. It's got a lot of stuff on there. You want to go. So let's go to the next graphic. So this is what it looks like for those chemistry people out there.
I was gonna try to make a chemistry 6th grade chemistry thing, atoms and elements together.
It's the dichloro. That's 2 chlorines, and it's a silane setup. So silane is silicon and 4 hydrogens. So someone decided to put a couple chlorines in there.
And get rid of the hydrogens.
I don't know what they did.
I know, like what do you do with and then the hydrogens there? And
that's
and you can fill your blimps.
Okay, so let's go to the next graphic. So this has, Corey was talking about it. It's a low vapor pressure. Look at that. That's 70 degrees Fahrenheit. It's 8.6 psi.
And it's also very volatile in pressure because, as you can see, 10 degrees it goes up, it more than doubles in pressure.
It looks like it only goes up like 9. It's like double. But still, it's a very low vapor pressure gas, so you got a lot of things going on there. So you can take down the graphics. So we're going to talk about. There's a bunch of hazards associated.
The who, the what, the where, the when, the
how.
I
tell you, this is the hazard part. So you got something like that looks like dichlorosilane.
Well, no, dichlorosilane does follow my rule of it does sound bad.
It sounds bad.
Unlike sulfur hexafluoride.
Sulfur hexafluoride is not so bad.
Not so bad.
Except that it's a really bad greenhouse gas.
Well, okay.
So okay. So the next slide, we got this off our SDS from our corporate website. Next graphic shows the hazards.
So we have.
There we go. Hazards of dichlorosilane. It's toxic.
LC50 rat.
Okay, we'll just gloss over that one.
Okay, I thought.
So that's 314 ppm. And then they have the acute toxicity estimate. So that's like a short term. So 157 ppm. So it's toxic.
So bottom line, this is the theme of just know your gases. That's the safest. That's a way to be the safest you can be. Is know what's in your. And this one,
it's toxic.
It's toxic.
Flammability, 4.1%. So it's like a hydrogen.
That's a good.
It's got a hydrogen. It's got a couple H's in there.
Yeah.
Now this is the real nasty part of it.
Oh yes.
Chemical stability may polymerize violently or explosively. That's. Not just violently, but explosively. So that's
polymerize is a good word too.
Boy. Avoid contact with incompatible materials. That's a good idea. Combustible materials.
But what are incompatible materials?
Combustible materials, halocarbons, oxidizing materials, and the big one, water.
Yeah, incompatible. They're like the aliens from Signs.
Yeah. Oh,
right?
geez.
Yeah.
So water.
You throw water on them, they were incompatible.
Yeah. Well, no, it's gonna react violently with water.
Just like the aliens in Signs, they reacted violently to water.
Okay, you can take that graphic down. That's enough. Okay. So it's so it's got some hazards in there. Now, for chemicals we talked about chemical stability and stuff.
Yeah.
Now, material compatibility. We don't have a chart for this.
No,
but it's with this mainly because of water. You want to stick with stainless steel, Monel. It is compatible with brass, but brass will suck moisture in there, so that's not good.
Brass is more porous, even though you don't think of it as being porous because it's very microscopic pores.
Yeah. And that's Cal-Res O-rings, not your Typically, things have Viton or neoprene or Buna O-rings. No, those won't work. It's got to be Cal-Res. So with your regulator seats, just your normal Cal-F, PTFE seats are good enough for that. So it's the Cal-Res O-rings that you have to change out. Anything with the check valves or relief valves, check. Yeah. Okay, now usage.
Yeah, why do we have such a dangerous gas? Why do we even make it?
Yeah, I know.
And it obviously was. Like I looked, it sort of was like we need silane in a gas, and it could work. And they're like, let's just put it together and see what happens. And it's kind of
I don't know why they came up with it, but it's chemistry guys.
Yeah, was it? Yeah.
And it's Okay, so dichlorosilane is used as a starting material for semiconductor, silicon layer, and microelectronics.
Mm-hmm. Yep.
So
just like
chips.
everybody knows what that is.
Yeah, so it helps in making computer chips.
Yes.
So you're not using like happy gases to make computer chips. You got some nasty ones in there. Its advantage is, why would you want this? Is that it can decompose at lower temperatures and has a high silicon crystal growth rate.
Yeah, that silicon crystal. But Silicon Valley is made, to grow that valley.
Chips. Yeah. Oh no, jeez.
It's like, well, no. Superman Returns, when they try to grow that kryptonite island, Lex Luthor.
Okay.
That's what they're trying to do here.
Lex Luthor's dead.
Is he?
Okay.
No.
So it's used for silicon industry, making chips, making chips, so you can have
not the eating chips either. Just be clear.
Yeah, we forgot I was going to bring.
Not potato chips.
Yeah, I'll blame you for not bringing that.
Microchips.
Microchips, really small chips. It's like the crumbs in your bag. Okay, so some equipment talking about. This is our 3452 regulator. Mm-hmm. It's a low delivery pressure line regulator. It's kind of big, so it has a large diaphragm.
And the one thing, well, I don't know, I missed if you mentioned it, but this is on our website, store.mathesondask.com, specifically for what reason?
Dichlorosilane.
It was before we got here, and it was like, wait, what is this?
Someone asked that question. No, is this regulator good for dichlorosilane? And we looked at the description. It says, this is for dichlorosilane.
We were like, that's interesting.
Because it's a low vapor pressure gas, you don't want to have a lot of restriction. So this is a 0.6 C/V regulator. And it's got a large diaphragm, which helps with stable pressures. Yeah, stable pressures.
More area.
Dial in your pressures and stuff like that.
For more flexibility in the.
So this is a high flow rate regulator. It's like our 3200, but it's got 1/4 inch inlet and outlet.
Cooler.
It's cooler. It's got a cooler name. And then. So that's if you just need a regulator for it. If you want a panel,
and also this one's also just a regular line. The setup as a line regulator.
As a line regulator.
Is there a? I mean, can you just take this and put it on?
Yeah, you could put it on. Yeah,
so
you can. Because yes, and it doesn't have an inlet pressure gauge. Because you don't need one. The pressure's
nothing. Yeah, it's going to get it to 30 if you're unlucky.
Yeah, if it's a hot day, it's going to be 20 psi. Okay, you want to toss up the next graphic? Ta-da!
That's what we did.
That's a 9400 series panel in a cabinet. That's on our production floor right now. Someone ordered one of these things, which is great.
And what's interesting about this is, as well as you got it with a 5-panel, which has a purge.
Yeah, and we're going to go to the next graphic. So that's got a rigid pigtail in there. Next graphic is a zoom in. It shows you.
Yeah, there we go.
Yeah, it's got a cross purge setup. Those are those valves there, the PGI, HPI.
But why would you want a cross purge setup for dichlorosilane?
Oh, you don't want it. It doesn't
like water.
Well, it likes water, but it reacts violently.
Well, yeah, it likes water, but not in the way we like it to like water.
You don't want it to mix up.
Yeah, it's a torrid love affair.
It's kind of like that. Yeah, it's kind of like that hot sauce.
Yeah, it's not the nice
one.
You
might like that hot sauce, but it doesn't.
Yeah, there you go. Yeah,
your stomach doesn't like it.
So
it's got an ESO valve because if there's a problem, you want to have that valve closed.
Yeah, because you don't want it reacting with the water. Or if
right. Well, if there's an emergency situation. Yeah. We have on there an excess flow switch on the outlet. And that's so if there's a release down, if a high flow downstream, like the line breaks or something, it will trigger, and then the ESO valve will close. And there's obviously the purge gas inlet, so you can purge things out. Typically, dry nitrogen, clean dry nitrogen.
Yeah, to get the moisture out. And other.
Okay.
Now, and it's great for getting other impurities out if it's something gets in there.
You can take that graphic down. So another thing that we don't sell, but it's important with this is call it heat tracing. Now you've got a low vapor pressure gas.
That's very volatile depending on how warm or cold it gets.
And
right. Percentage-wise.
Well, actually, there's something called, and this is one of these Joule-Thomson effect. And what that is, remember
Joule's
that.
like a diamond on a ring?
No, Joule, Joule,
Okay.
so like energy guy. And
Thomson.
Thomson is really Lord Kelvin, so it can be called the Joule-Kelvin effect.
Kelvin's way better than Thomson because there's
cool,
a lot of Thomsons, not a lot of Kelvins.
Yeah, so this is one of these terms you can use if you're in a cocktail party with engineers. You bring up, I think you got to take into account the Joule-Thomson effect.
Shall we have tea and talk about the Joule-Thomson effect?
Yes, something like that. Now, what it is that, especially with valves, when you have gases go through valves, an orifice, so it's restricted, the temperature will drop. Mm-hmm. So when you have a vapor, what's important is like you have a liquefied gas, the temperature could drop, and then the liquid could drop out. It could drop out as a liquid. Sort
of what happens with the ice balls that form, it's a little bit.
Yeah, when you see cooling and stuff. Well, it's how air conditioning works.
Yes, exactly.
You use a liquefied gas. You go through an orifice. The temperature drops. It gets cold, and now your house is comfortable. Mm-hmm. So you want to toss up the next graph. So this is from our gas data book. I
zoomed
took a
in.
Bad picture of it. I zoomed it in because it goes forever. So 0 to 100 is a good temperature range.
Because typically we're 0 to 100.
Yeah. So, yes. So you can see there on that line tells you that's the the temperature, like let's say right there, 15.3 psi. That's probably about 80 degrees Fahrenheit. So so you got it at 80, and now it chills down to like 40 or something, or 50 psi. The pressure's going to drop.
Drops by a third or two-thirds.
Yeah, it's a significant drop. So you could have it drop out as a liquid. Now you could have, if the line's cold, and you don't put heat back into it, you could have liquid go when you're expecting to see gas and you get liquid.
It doesn't seem, it's only 10 psig, but you have to look at it for like the factor, like how much.
Yeah, so it could become liquid. So you can take the graphic down. It's not that good graphic.
It's not. It's on your favorite logarithmic scale.
Yeah, well, actually, that's a single logarithmic scale.
Yeah, not a double, which makes it a little bit. Yeah.
Okay, so a lot of semiconductor fabs will heat trace their lines to make sure that you don't get liquid. Because if you're expecting gas and you get liquid, that's kind of a bad thing.
It also keeps the pressure consistent.
Yeah,
as
keep the pressure consistent.
Which is or even getting it out of the cylinder. You want it a little bit warm to maybe get more out of the cylinder.
And sometimes with these low vapor pressure gases, they'll be, if it's a higher flow rate, they'll put a heater jacket around it to keep it so you don't have that cylinder pressure drop to nothing. Sometimes people do that. Okay, so purification. So especially in semiconductor industry, they want really super clean stuff. And this is an example of a white knight. This is one of our nanochem purifiers. And where can you buy this?
store.mathesongas.com. And it's a white knight, not N-I-G-H-T, right?
It's K-N-I-G-H-T. Goes with Kelvin.
Goes with Kelvin, yes.
Okay.
Makes me think of Monty Python.
So this has the media inside, the magic stuff inside.
The magic beads.
There's none in here. This is a demo.
Yeah.
But 4-dichlorosilane.
Especially for nanochem, because nanochem can go. It has a shelf life, right? Pretty much.
No.
Oh, it doesn't. Okay.
So we have MTX media in here, and that's the stuff we use on that. So you wanna toss up the next slide? Okay, so this is the White Knight NanoChem corrosive gas purifier, and it shows you there for the corrosives and the SiH2Cl2, that's dichlorosilane. And it shows that it will get your moisture down to 1 part per billion.
Wow.
And it'll take out some volatile metals.
HBr, HCl.
Yeah, so it's got those it'll take down, and it's so I guess that's important in there. And,
well, no, I mean, it's just taking out,
I guess you want pure silicone. You don't want to have some titanium floating about in there. I don't know how you get it in there. Or sodium or zinc or aluminum or any of that kind of stuff.
Molybdenum.
So you could take...
Am I right? Molybdenum?
You could take that one down.
Yeah.
And then we've got a little study that we did. You want to put up the next graphic?
And there'll be a test afterwards.
Yeah, so we did a test. This is back in 2008 on MTX purification. This is with dichlorosilane. And you see that little graph thing going on, and you got that one baseline down low. So you want to be so the higher the number, the better. So there's intrinsic resistivity.
Yeah,
that's enough. So you can see that when you're running the MTX, it's way up high. It's really good, and you got with the bypass off, it's not so good. So this helps out with that. Obviously, you're cleaning up the impurities. So you can take that slide down. So yeah, the NanoChem purifiers for really super purification stuff.
And NanoChem's a newer
and
product.
And you can't use like our other standard purifiers with that because it would just chew everything
they're not for corrosive. Yeah, pure gas is not for corrosive.
Yeah, our pure gas and all that other stuff's not. You need something like the NanoChem. White Knight. So these are. We can ship these, if you order it, it's like 3 to 5 day lead time. That's not too bad.
It's not too bad. It gets you clean.
Something really
it makes it safer too.
Sophisticated.
So, get some moisture out.
Yep.
No, go ahead.
Oh, that's all we're going to talk about.
No, I was going to say bottom line is we're stressing it, know your gases.
Yeah, know your gases.
I know this isn't the most exciting topic as we go through. This is what and even if you don't pay, I don't care. Just know that when you're doing your own gas, you can use this as a guide to be like, I might have to look at this stuff. I may have to, just that's all we want. So
one thing we forgot to show.
Oh, the seat I've been playing with the whole time. That's why.
Yeah, it's warm, man. Okay.
It is. Well, I want to make sure the gas flows.
Dichlorosilane has, for a standard cylinder, will have a 678 fitting. Ooh. It's kind of a goofy looking flat face washer thing. It's got a recessed thing, and it
comes with
washer.
Your little guy right there.
A little Teflon washer there. So this is for.
Or as I like to call them, Teflon washer.
There's also disc fittings. I didn't want to get those out because those would be bagged up. So yeah, so that's it for dichlorosilane. That's all we're going to talk about today on that. Next week, we're going to talk about manifolds fitting in tight places. So there's so it's next week you're going to learn about just if you got a situation where, hey, that manifold's a little too big.
It's like Tetris a little bit. I mean, I gotta fit. Yeah, fit it in there.
Kids with their video games. So.
What do you mean, kids? That was people that played Tetris are like 60 by now, aren't they?
Oh, please. I played Tetris when I was in college.
I win.
It was black and white. So tune in again next week for another live edition of the Bill and Corey Show.
Set your VCRs.